Bismillahirrahmanirrahim. Assalamualaikum and good day everyone. Inshallah today we're going to continue our chapter 3 entitled as vector. So the first part of this topic will be coordinate system. Okay, we have two kind of coordinate system. The first one is Cartesian coordinate system. By the way, what is the use of the coordinate system? It is used to describe location in two dimension for the xy axis in this case. Okay, so first one we have Cartesian coordinate system where we are going to do the reading the information from x-axis as well as the y-axis. These two axes going to intersect at one point, we call it origin. Alright, so if you refer to this one, let's say point P, okay, 5, 3. What does that mean? You still remember or not? So when you have a reading of a point like this one, you have a reading of point of the x-axis information firstly, followed by the y-axis information. So means that 5 here is 5 unit to the right because it's positive along x-axis, and 3 unit to the top along positive y-axis. How about this one? Why is it negative? Because it's to the left of the origin. Second part is second type of the coordinate system is polar coordinate system. For polar coordinate system, we have this manner, not xy only, but we also include r and theta. What is r? Within the r is position actually. R is position, where we have information of x and y within r. Okay. But then addition to that, we have another thing which is the angle between the fixed axis to the line drawn from origin to the position of the object. Right. So within this information, this is your R. Okay. Within your R, you have X and Y information. But addition to that, you have angle information. And this angle normally going to be measured from positive x-axis. So coordinate system. Okay, just now polar coordinate system, you have information of r and followed by the theta, and within r we have x and y information. Therefore actually this information can be converted into this triangle information. So you have this angle, you have the r, x and y information. So from here you may use it to figure out sin theta, cos theta or tangent theta. Okay, for example, by make use of cos theta, okay, you have here, right, you have cos theta is equivalent to x over r. Therefore, to have x only is r cos theta. Okay, or for example, you want to have information of y. Then you're going to have, let's say, sin theta. So, sin theta equivalent to y over r. So, y only is r sin theta. Next one, you may also make use of information for the tangent theta. Tangent theta is equivalent to y over x. Okay. And how about to get, if let's say, not given to you the r, instead is given to you the y and the x. Since this is a triangle, so to have a value, magnitude of the r, you may use Pythagoras. Okay, so you will get information of r itself. Alright. Next one, 3.2 vector and scalar quantities. For scalar quantity, you still remember, I believe, okay, it has only value or magnitude without direction. Okay, but for vector quantity, it consists or it has both of the information, value or magnitude, as well as the direction. Okay, so basic arithmetic, okay, in vector, all of these arrow or vector point in the same direction along parallel lines and same magnitude. It means that they are the same in magnitude and direction. Direction can be observed by using the tip of the arrow, but then the magnitude, the length of the arrow. If the length is the same, then it is the same value or magnitude, right? So to have vector A in general, okay, to have vector A equivalent to vector B is only happen magnitude of A is the same to the magnitude of vector B. Okay, vector addition. This one is head to tail method. This is drawing method actually. Okay, even if you are not familiar, you can just sketch about how to do this head to tail method. It's just drawing or sketching technique, right? So let's say you have here, okay, the process of R, the resultant of your vector is actually addition between vector A and vector B. So in terms of drawing, okay, is actually you draw A followed by B, then connect from tail of the A to the tip of the B. This is taken from your textbook. So let me do it for you. Alright. You draw A. Firstly, you draw A. This is your vector A. And then secondly, you draw your B. This is a second vector. Which to draw first? Okay, according to this. Right. Then now your resultant from tail of the A, the first vector, to the tip of the B, which is your second vector. So this is your R, right? Where it is actually a product of A plus with the B. That's the meaning, right? Okay, now you may also actually rearrange in term of the arrangement. If let's say you have let me divide this. You have A plus B in this case, firstly. Okay, you may also put it as B plus A. So how to draw it when you have B plus A? So you draw B first. Okay, this is your B. Then you draw your A. This is your A. And then tail to tip method again. So this is your R. So it's just like you are taking another path, isn't it? In this path. So we call it parallelogram method. Okay, further to this. Right. So either you are doing this or you are doing this, you will get the same resultant. Right. So next one. Okay, next one. Okay, is this figure. Right. Where you have three vectors. R is product of A plus B plus C. Okay, so tail to tip method. Okay, let me show you on how to get this. Alright, you draw A, and then you draw B, and then you draw C. Finally, okay, you're going to have tail to tip, tail of the first vector to the tip of the final vector. So you are going to have your resultant here, where the resultant is actually addition of A to the B and C, like that. Okay, more or less. Okay, and then you may rearrange the position of each of the vector, because A plus B plus C is also equivalent to B plus A plus C, also equivalent to C plus B plus A. So it's up to you. So the way you're going to arrange this is up to you. Make sure you will get finally the same direction of R. Okay, then you are doing the correct way. And for rearranging, okay, for example, just now, A plus B plus C, in bracket like this, in parenthesis like this, equivalent to actually A plus B parenthesis plus C. It's just the same actually. So this kind of method we call it associative law of addition. And this method we call it commutative law of addition. Okay, what I'm referring to, okay, this is the thing. Right? Vector subtraction and scalar multiplication. So if let's say if you want to do A plus negative of A, you will get what? 0, right? Correct. Okay. And how about A minus B equivalent or not? A plus negative of B. Yes, it is equivalent to. It's just the same thing, right? Okay. So for this diagram, okay, if let's say you want to do A minus B, okay, A minus B. So firstly, you have the vector A, okay, and then you have a vector B. Let's say vector B is this one. Alright, and then since the process that you want to do is A minus B, then you are going to transfer the vector B to the opposite direction, because to display negative direction. Okay, so you are having dash line means that this is imaginary, no more B here. The B already reverse to this direction and place here. So from tail of the A to the tip of the B, then you are going to have this as your resultant. This is your resultant actually. Okay. So how to do that? Okay, for figure B, okay, the process that needed to be done is C equivalent to A minus B. Is the vector, which one? The C, okay? Is the vector we must add to B to obtain A. Oh, what does that mean? Okay, it's like this. Since C is equivalent to A minus B, this is the real process, the actual process that needed by the question, let's say. So we can rearrange this equation in terms of, alright, C plus B is equivalent to A. That is the meaning of this word. C is a vector that we need to add to the B in order to get A. Alright, so how to do this in terms of drawing? Okay, how to do this? Okay, how to do this? If you are talking about C, if you have A here, okay, similar or not to this, same direction, right? Same length. And then you have B here, okay, and then you have you have another vector to add up to the B in order to get to A. Okay. So in terms of drawing, firstly, you have B. You have vector B. And then you need to add one vector. You need to get here. This is your vector A. You need to get here, this final point. Okay. You are starting from B. You are moving along B. Okay. But you need to get here, the final point, the tip of the A. So you need to move here, isn't it? You need to move here. So when you move, you need to get to the A. Okay. So this is your vector C. That's the meaning of the whole. That's the meaning of this statement. Okay. This is the C. So that is why we may write the C is equivalent to A minus B. Alright. Or you may play around with this, rearrange it according whatever you like to. Okay. And then this is a vector subtraction and scalar multiplication. What does that mean by scalar multiplication? You may double, triple, quadruple the A, the B, the C, okay, by using scalar multiplication, where you may write down like this. Okay, at any instant, if let's say 10 times, okay, bigger than A. So meaning what? New vector that you're going to have, let's say vector D, is equivalent to 10 times vector A. That's the meaning of scalar multiplication. Right? Half of A, 1/3 of A. So variation of it. You may do it in variation time multiplication process. 3.4 components of a vector. Let's say you have a single vector, okay, where you have A only here. Okay, for a single vector here, actually you have a combination of AX and AY. Okay, where the A is covering certain angle theta from positive x-axis. You may rearrange the position of the AX and AY, okay, to this position for AY, like for example. Instead of putting it here, you may switch it or rearrange it to this position. Okay, you may also rearrange the AX. Let's say you may put it here. This is a AX. No problems. What about the angle? The angle going to be here. Okay, because the angle here and the angle here is the same angle. Right, and here 90 and here 90. Alright, so make use of this information. Right, you may figure out any unknown, let's say AX. Right, how to get AX? AX is your unknown. Okay, so you may use cos theta. Cos theta equivalent to AX over A. Therefore, AX only is A cos theta. If let's say you want to figure out Y, so may use sin theta. But it's not a must, okay, to deal with the X all the time is cos theta. No, it's not a must. It will depending on which angle that you are referring to. So for this case, sin theta is AY over A. Therefore, for AY only is A sin theta. To the respect of this angle, okay? This angle, purple angle here. Purple color. Okay. How about magnitude? magnitude of the A, okay, the hypotenuse, the A, is equivalent to magnitude of A, square root of, forgot the arrow, square root of 8x square plus ay square. Right. How about the theta itself? The direction. Theta is arctangent of ay over ax. Alright. It's not a must to get the x component by using cos. What does that mean? For example, let me show you for another angle. Let's say we know here 90 degree. Here you have, let's say, alpha as your angle. By using alpha, now you want to know the ax. Given to you the A. Right? So, if you are using cos alpha, okay, so how is it the formula cos alpha? Adjacent cos alpha, adjacent, which is ay, over hypotenuse. So if you see here, by using cos function, okay, you will get information of ay. So it's not a must that to get x component, you have to use cos function. No, it depends on which angle that you are using or referring to. Okay, for this case, you are going to have ay equivalent to a cos alpha. Okay, how about sin alpha? Sin alpha, ax over a. So from here, you will get your x component equivalent to a sin alpha. So do not memorize that to get information of x component, you are going to use cos all the time. It's wrong. Okay? Or vice versa. To get y component, you have to use sin function all the time. No. It will depending on which angle you are referring to. Okay, you may also use tangent actually. Okay, it depending on what you have in your hand, the information given to you. You have a situation. Okay, this is your reference axis. This is your x. This is your y. You have your first vector is, let's say, vector A. Vector A. Certain angle from positive x-axis. Okay. What is the component for your ax? Here, right? This is your ax. Positive or negative? Positive. Why is it positive? Because it's pointing along x-axis. Because it's pointing along x-axis. What about the component of y? Here. This is ay. Positive or not? Positive. Why is it positive? Because it's pointing upward to the positive y direction. Okay. Let's say you have another vector. Vector C. Okay. Certain angle here. Right. So where is CX? Somewhere here. Positive or negative? Positive. Why is it positive? Because it's pointing to the positive x direction. Right. Where is the component of the y? For C, it's here. This is CY. Positive or negative? Negative. Why is it negative? Because it's pointing downward to the y, to the negative y-axis. Let's say you have another vector. you have here vector B. Okay, does vector B has any x component? No. Why is it so? Because it's pointing along y only. Along y only. There is no component in terms of x. Next one. Let's say I have another vector. In this manner. This is the angle of the vector. This is vector D, let's say. Right, what is the component of dx? Dx going to be here. This is dx. Positive or negative? It's positive. Okay, it's positive dx. Why is it positive? Even though it is placed within the second quadrant. Because it's pointing to the right, to the positive x-axis. Okay. Then the y component here. Right? So this is dy. Positive or negative? It's positive or negative? The answer is negative. Why is it negative? Because it's pointing downward. I have another vector. Where to put it? I want to put it like this. It's not touching. This is vector E. It's not touching the origin. Can we determine? Yes, we can determine the component of it. We can shift it to this position. Okay, this one going to be this is the original, already shifted here. So what about E? The vector E only has x component because it's along x-axis, and it's positive because positive or negative? Negative because it's pointing to the left. Okay, from all of this drawing, you may transfer it in simple to this method. Okay, you put it like this. Okay, so this is your vector. This is your x component. This is your y component. To make sure there is no confusion, so please follow this one method. Right. So we have vector A firstly. Okay, x component is positive. Okay, where you're going to have A cos theta. Right. For the y component, it's A sin theta, and is also positive because it's pointing upward. And then for vector B is only consists of y component, therefore the A is 0. So y component, the B itself, right, the magnitude of the B itself. And then vector C, for vector C you have a positive x component, which is C sin theta, the black color theta there, the black color theta. Because if you transfer this black color theta, it will be here, isn't it? That is why it's sin to have x component. Right? Then for y component, for y component, it's negative. Negative C, the hypotenuse, cos theta. Right. And then next one, For vector D, alright, for X component it's positive, it's the hypotenuse of it, cos theta. Okay, for Y component it is negative, it's pointing downward, it's d sin theta. Right, and then for vector E, Y component is 0 because it's completely lies on x-axis, but then it's pointing to the left, it's negative E itself. Right, then from here, okay, figure out the summation of everything here. This is your resultant, means that summation of every single thing here, sum. Okay, then you will get, okay, this is your R in terms of X. Okay, consider the negative sign as well, take into account as well. Then you submit everything in this one, this is your R, Y. Okay, you're going to consider every single thing that side. Okay, negative as well. Then next step, what should you do? Okay, this is in terms of component. You need to do another step, magnitude of your R, by using Pythagoras. Then the direction uptangent of over Rx. This is what you should do. The first step, resolve. Second step, table. Third step, magnitude calculation. Fourth one is the direction.